Hello, hi, how are you everyone? Namaste and welcome back to SJA CTET classes. So today in this video, we are going to see regarding cubes and cube root. So which are the methods to find out cubes and cube root? So please don't skip the video. Watch from the beginning till the end of the video. Okay, I have quoted examples also for you. Okay, so without wasting much time, we'll start. Before that, let me remind you, if you're watching my channel for the first time, please do like, share and subscribe. Okay, so let's start. Yes. So what do you mean by cubes, everyone? A number multiplied twice by itself. Then the result of this multiplication is called cube of that number. For example, 6 cube means what? 6 into 6 into 6. So that is, you'll be getting 216 as the answer for this, right? Next. And cube by using algebraic identity. So the first method we are going to discuss is cube, how to find using algebraic identity. So let's see. We have the algebraic identities a plus b the whole cube as a cube plus 3ab into a plus b cube, and a minus b the whole cube is equal to a cube minus 3ab into a minus b cube. So this we are learning in the smaller classes like 8, 9, so that we are able to apply here. For example, how to find out the cube of a 2-digit number 47 using this algebraic identity. So first let us write how we can rewrite 47 as. So 47 can be written as, everyone, 50 minus 3, as everybody knows, right? So 47 cube means we can write it as 50 minus 3 cube. Okay. So now it is of the form a minus b the whole cube, right? So what is the expanded form says? A cube minus 3ab into a minus b cube. This is the expanded form. So we will be understanding here as a is equal to 4 and b is equal to 7. We have to assume accordingly. Okay. So we'll substitute what we'll be getting. So let's see. So 47 cube is equal to 50 minus 3 the whole cube. That is equal to a cube. That is 50 cube minus 3ab. 3 into a is 50 and b is 3. So 3 into 50 into 3 within bracket a minus b. That is 50 minus 3. And then it has to be multiplied minus, we have to find out 3 cube, that is a b cube, right? So here 50 cube is 5 cube is 125 and the cube of 10 is 1000, you know. So 125 and 3 zeros will come here. Then 3 multiplied by 50 multiplied by 3. 3 3s are 9, 9 5s are 45. So 45 and 1 0 because of this 50. Then multiply by 50 minus 3, that is 47 minus 3 cube is 27, right? So let us calculate what is 45 into 47 here. 7 5s are 35, 3 carry over, 4 7s are 28, 28 plus 3, 31, 4 5s are 20, 2 carry over, 4 4s are 16 plus 2, 18. So we'll be getting 5, 1, 11. So here it is 2. So what is the answer we are getting here? 1, 2, 5, 000 minus 2, 1, 1, 5 and 0 because 450 is here. We multiplied only with 45, right? Minus 27. So here this minus 21,150 and minus 27 is there. So same symbol. So we will be adding and giving the same symbol. So 1, 2, 5, 000 minus 2, 1, 1. When you add 27 to this, it will become 77, right? So now we can subtract it. So 1, 2, 5, 000 minus 2, 1, 1, 7, 7. So when we subtract, what will get? 10 minus 7 is 3. 9 minus 7, 2. Again 9 minus 1, 8. 4 minus 1, 3. And 2 minus 2, 0, 1. So we'll be getting the final answer as 103823. So you can check whether it is correct. Yes, you will be getting 47 cube is equal to 103823. So this is one way of finding cube using identity. So here one more identity I will be applying. Here finding the cube of 103. See everyone, 103 can be rewritten as 100 plus 3, right? Yes, so we can understand 103 cube means 100 plus 3 the whole cube. Okay, so now we can use the identity. Which identity we will be using here? A plus b the whole cube. Okay, what is a plus b the whole cube, everyone? A cube plus 3ab into a plus b cube. Okay, now here we could understand a is equal to 100 and b is equal to 3. So let us substitute accordingly. So we'll be getting a cube. A cube is 100 cube plus 3 into A, 100 into 3 into A plus B, that is 100 plus 3 plus B cube, that is 3 cube. So what answer will be getting here? What is the cube of 100? So whenever the number of zeros are there, so we have to multiply the number of zeros thrice in order to get the number of zeros in the cube of a number. So here 2 zeros are there now. So 2 threes are 6. So we will be having 1 with 6 zeros. Plus here 3 threes are 9, 900. 900 multiplied by 100 plus 3 is 103 plus 3 cube is 27. So what answer will be getting here? 1 and 6 zeros plus 103 into 9 will multiply. 9 threes are 27, 2 here and 9. So we'll be getting 927 and 2 extra zeros are there because it is 900 multiplication plus 27. So let us add 1 with 6 zeros plus 92727. So when you add, what is the answer? Plus 92727. We'll be getting 10922727, right? 10922727. So you can check that the cube of 103 is 10922727. Okay. So this we have utilized here two examples. One example I used a minus b the whole cube, and another example I used a plus b the whole cube. Okay. So you can use accordingly. Now the cube of a fraction. So how to find out the cube of a fraction, everyone? So cube of a fraction can be find out by taking the splitting or the distribution of the cube can be given to the numerator as well as the denominator. For example, cube of 3 by 5. So you have to rewrite it as 3 by 5 the whole cube. Okay. So in the law of indices also we have learned that what is that? A by B the whole raised to n. The distribution comes like a raised to n by b raised to n, right? So 3 by 5 the whole cube can be written as 3 cube by 5 cube. So the answer will be 3 cube is what? 3 multiplied 3 times. So that is 27 by 125. So fraction, you can directly apply the property that is a by b the whole raised to n is equal to a raised to n by b raised to n. Then cube of a decimal number. How to find out the cube of a decimal number? First of all, ignore the decimal point and then find the cube of the given number. See here 1.36 is the question which I wrote, and without decimal we can write the number as 136, right? And first of all we have to multiply and find out what is the answer of it, the cube of it. So that means we have to multiply 136 thrice. Okay, what answer we are getting here now? So put the decimal point in such a way that the number of decimal places in the cube is 3 times the number of decimal places in the given number. Actually, here in this question, we just need to focus on, we know how to multiply, right? So here we just need to focus on what is the number of decimals we can give it to the answer. So here if we have the answer as 2515456, this will be you are getting after multiplication, and on this number here in the number which we have to find the cube, it has only 2 decimal places. So answer should have 2 into 3. What is 2 into 3? 6 decimal places. So you can count from the right and towards the left. So we'll be able to see that 1 2 3 4 5 6. So after 5, from right towards the left, you have to put the decimal and you'll be getting the answer 2.515456. So in order to make you aware of the decimal position, I made this question to you. Okay. So otherwise it is same as finding the cube of a number. Now, you have to remember one thing, the cube of a number from 1 to 10. That is very, very important. So always you should have that in your mind. It will be easy for you to identify. So especially for competitive exams like CTET. So here x and x cube. So what is 1? 1 is the number which we need to find out the cube of. So 1 cube is 1, 2 cube is 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube 216, 7 cube 343, 8 cube 512, 9 cube 729, and 10 cube is 1000. So these all you have to have it in your mind every time. Okay, so it will be easy for you. Then what are the properties of a cube number, everyone? First property, the cubes of numbers are having unit digits 0, 1, 4, 5, 6 and 9 also ends with the same digits 0, 1, 4, 5, 6 and 9. See, for any number, when you find out the cube of that number, the numbers on which the unit digit are either 0 or 1 or 5 or 6 or 9. For these 5 digits, the same digits will be coming the unit digit when you find the cube of the number. Okay, the given number is having either any of these digits as a unit digit. When you find out the cube of that number, you will be seeing that the unit digit will occupy by the same digits. Okay. Now, the cubes of numbers with unit 2 will end in 8. That means unit digit 2, if it is there, the cube will end in 8. Okay. And if a number is having unit digit 8, when you find out the cube of that number, it will end in 2. You can multiply and see that. Now, cube of a number on the unit digit, if it is 3, and it will be ending. When you find out the cube of that number, you will be getting that the unit digit is 7. When a number is ending in 3, the cube will end in 7. When a number is ending in 7, the cube will end in 3. So that is what. So likewise 2 and 8. So that is each other. That is, it is coming each other, right? So the same way 3 and 7 will also simultaneously coming opposite to each other when you find out the cube of the number. Okay. Then odd number cube are always odd numbers. When you find out the cube of any odd number, you will be getting odd number as an answer. For example, 5 cube is what? 125, right? Then what regarding the even number cubes? When you find out the cube of an even number, for example, if you are finding the cube of 6, what is the 6 cube? 6 cube is 216. It is even number. So cube of odd numbers are odd numbers and cube of even numbers are even numbers. Okay. Then cube of a negative number is negative. Cube of a negative number is negative number. Perfect cube can be negative. So negative numbers are coming because when 3 number of negatives multiplied together, the answer will be negative only, right? So perfect cube can be in negative. And checking for perfect cube. So how to check whether a given number is a perfect cube or not? Okay. So for a perfect cube, if we want to find out that, when we prime factorize that, so the prime factors should come in one digit at least at exact 3 times. At exact 3 times, one prime number should come. So otherwise the grouping cannot be done. So we will see that through an example. For example, I have a number 9261 here. Okay. So I'm going to check whether this 9261 is a perfect cube or not. Okay. So if I need to check that, I have to prime factorize this. Okay. So what is the smallest number, prime number I can divide it out of? It is a multiple of 3. So I can divide by 3. So it is 3 and 0 here. 8, 24, 24 and 2, 21, 7. Then again dividing by 3, 1, 0, 2 3s are 6, then 27, 9 3s are 27. Again by 3, you will be getting 3 3s are 9, 1, 12 is there, then 4 3s are 12, then 3. Okay, so again this is divisible by 7 as we know, and we know that 4 sevens are 28, then the balance 63, so it will be 9 sevens are 63, then 7 again to be divided, so you'll be getting 7 sevens are 49. So the prime factorized form of 9261 is equal to 3 how many times? 3 3 times and 7 3 times. See, here we can make a prime number as a group of 3, right? And when you find out the cube root of this number, what you have to do is you just need to take one element from one group. So here a group of 3 is there, a group of 7 is there. So from the one group of 3, you just take 1 3, and from the group of 1 7, you can take 1 7. So you'll be getting the answer 21. So you would understand the cube root of 9261 is 21. Okay, so this is how that you are, if we are not getting the groups like this, for example, here we got only 2 sevens, we couldn't say that it's a perfect square, right? So in this way you can check it. And one more question we can have here for checking. For example, 7744. Okay, so let me check it. This is 2 is the least prime number I can divide out of it. So this 3 2s are 6, 17, then 8 2s are 16, then one carry over 14, 14, 7 2s are 14, then 2 2s are 4. Then again dividing by 2, 1 2, then 18, 9, then 3, then 12 will come, that is 6. So again dividing by 2 will be getting 9 2s are 18, 1 carry over 13, 6 2s are 12, then 116, it is 8. Then again by 2 will be getting 4 2s are 8, 16, 8, it is there, then 4 2s are 8. So again dividing by 2 will be getting 2, and here 4, then 2. Again by 2 will be getting 1 2 1. 121 is a multiple of 11, so I can write it as 11 into 11, right? So the prime factorization comes like 7 7 4 4 is equal to, how many 2s are coming? 1 2 3 4 5 6. 6 2s are coming, 4 5 6, and then 2 11s are coming, right? So here you can see we can form a group, two groups of 2 here, because 3 times that is coming here. One group you can see here and one group you can see here, and but here you can see that only 2 11s are coming. We couldn't make a group of 3 here of this prime number 11, so we couldn't take, it's not a perfect square. So that is how we can understand that 7744 is not a perfect cube. It's not square, perfect cube. Perfect cube. And if we need to have it as a perfect cube, what we have to do? We have to multiply another 11 to this. When you multiply another 11 to this, you will be getting this as a perfect cube. Okay. So this is how checking. Next, the difference between the cubes of two consecutive numbers is 1 more than 3 times the product of numbers. So let us see what the property says. For example, if we have consecutive numbers like 5 and 4, okay, so it is 5 cube minus 4 cube. So you will be able to know how easily we can find out. In order to find out, no need to find out 5 cube first of all, then 4 cube, then we need to subtract them. So no need of that. You can directly find out the answer by using the formula. What is the formula? N cube minus n minus 1 the whole cube is equal to 3n into n minus 1 plus 1. Very, very important. This will be helping you in the examination. So here n cube means the first number and n minus 1 is the consecutive number, just one less than that. That is the predecessor, right? So here 5 cube minus 4 cube. The same way we could say, for example, if we have 5 cube minus 4 cube, we can know that this n is equal to 5 and n minus 1 is equal to 4, right? So then we can apply in this formula 3n into n minus 1 plus 1. How that we'll do? 3 into n is 5 and n minus 1 is 4, then plus 1. So here we'll be able to see 5 4s are 20, 20 into 3, 60. So 60 plus 1. So we'll be getting easily the answer as 61. Okay. So that is how we'll be able to check this. Now, cube of a number, column method. How to find out a number using column method. So for this number 38, how to do it using column method? So we have to have 4 columns. First column consisting of a square, a cube. Then second column consisting of 3a square b. And the third column consisting of 3ab square. And the fourth column consisting of b cube. Okay. So here you have to understand a is equal to 3, the first digit of the number, and b is equal to 8, the second digit of the number. So when we apply, we'll be getting a cube, that is 3 cube. Then 3a square b. 3 into a is 3, right? So 3 square into b. b is 8. Then 3ab square. 3ab square means 3 into a is 3 and b square, that is 8 square, and b cube is 8 cube. Okay. So we could understand 3 cube is 27. So first column we can segregate it into 4 columns, so it will be easy for us. Okay. So first column we go 27. Second column 8 3s are 24. 24 into 9. 216 you will be getting. So here 216, and then 3ab square. 3 3s are 9. 9 into 8 square. 8 square is 64. So 64 into 9. So 576 will be getting. 576. Then 8 cube. 8 cube is 512. So here, after getting this phone number, what you have to do is you just need to arrange the numbers, okay, from the right hand towards the left. So we need to take the unit digit here. So 512, we have the number, right? So from there, just take the number 2 only. So 2 we have here, okay. So the remaining number is 51, right? This 51 you need to add with this number. So when you add 51 here, what you will be getting? 6 plus 1, 7. 7 plus 5, 12, and here 6. So 627 you will be getting. So from this number, the unit digit only will be taking. So that is 7 here. Okay. Then the remaining 62 that you need to add along with the next number. Okay. So we'll be getting 6 plus 2, 8. 6 plus 1, 7, 2. So 276. So here also you have to take the number which is coming in the unit digit here. So it is 8 and the remaining number is 27. So 27 you need to add with here. So you'll be getting 54. So you can write the 54 as it is because there is no further procedure for this, right? So the answer will be 54,872. So you can check it. So 38 cube will be 54,872. Now, so regarding the cube roots, the cube root of a given number is the number whose cube is given number. So that means the cube root is denoted by the sign this. So that means whenever the cube root we are writing, so it is indicated like this. So cube root of p. For example, p is any number, so we can write it as cube root of p like this. So for example, cube root of 8. That means it is, the power is written as a fraction. So cube root of 8 is equal to, as you can see, it is 8 to the power 1 by 3. For example, cube root of 512. So how will you write? 512 the whole power 1 by 3. So this is what the symbolic representation for. So then you can normally find out how that cube root, it has to be prime factorizing the number and after arranging that and grouping, and from one group of 3 same prime numbers you can take one. Okay, the same procedure. Then what are the methods to find out the cube roots of numbers? So first one is method of successive subtraction. Second one, prime factorization method, and the third one is method of estimation. Okay, so the first one, let us see how to find out the cube root using method of successive subtraction. So which are the numbers here we need to successively subtract? So for that we should use this formula. What is the formula? 3n into n minus 1 plus 1. So you can give the values n is equal to 0, 1, 2, etc. Okay, what all needed? You have to substitute and find out. So when we give n is equal to 0, we will be getting what? 3 into 0 into 0 minus 1 plus 1. So it will be 3. So this term will become 0 and you will be getting 1 as the answer. So likewise, the starting number is 1 and 1, 7, 19, 37, 61, 91, 127, 169 and it will go on. So whenever you are giving the values n is equal to 1, 2, 3, 4, etc. respectively. Okay. So these are some numbers we have to by heart so that it will be easy for you. Next, so how we are using these numbers for an answer. So let us see here. I'm going to find out the cube root of 512. Okay. So here successively subtracted 512 minus 1. That is the first number. When you go 511, then the next number is 7. When you subtract, you will be getting 504. 504 minus 19, 485. 485 minus 37, you will be getting 448. 448 minus 61, you will be getting 387. 387 minus 91, 296. Then 296 minus 127, you will be getting 169. And 169 minus 169, 0. So at which step we are getting 0? How many steps we required for that? Here you can see 1, 2, 3, 4, 5, 6, 7, 8. At the 8th step, we got the answer as 0, right? So that we could understand the cube root of 512 is equal to 8. Okay, this is a successive subtraction method of finding cube root. Next method is method of prime factorization. This already we discussed. So if we need, we have an example here. For example, 1, 3, 8, 2, 4. So first of all, we need to prime factorize it. So smallest prime number 2. So 13 by 2. So that is 6. 1 carry over 18. That is 9 times. Then 2 1 time. 4 2 times. Again dividing by 2. 3 times. 4 times. 11. That is 5 times. Then 1. 12. That is 6 times. Again dividing by 2. We'll be getting 1. Then carry over 1, 14, 7, then 2 times, then 16, 8. So again dividing by 2, we'll be getting 8 times, 16, 12, 6, then 4. Again dividing by 2, we'll be getting 4, 3, 2. by dividing 2 again, 2, 1, 6. Dividing by 2 again, we'll be getting 1, 0, 8. Again dividing by 2, we'll be getting 5, 4. Then again dividing by 2, we'll be getting 2, 7. 2, 7, 27 can be divided by 3. We'll be getting 9. Then 9 by 3, 3. The prime factorization ends there. Right? So we can write it as 1, 3, 8, 2, 4. When we prime factorize, we got how many 2s? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 2s you got here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 2s are there. Then how many 3s are there? 3 3s we got, right? Yes, we can see here 1, 2, and 3. So 3 3s we got here. So we can group it now. So this is one group of 2, second group of 2, third group of 2, and the last group is of 3. So we have group, and when we write the cube root of 1, 3, 8, 2, 4, we need to take one element from one group. So here from this first group 1, 2, second group 1, 2, from third group 1, 2, and the fourth group 1, 3. We'll be getting the answer. 2 2s are 4, 4 2s are 8, 8 3s are 24. So you can understand the cube root of 13,824 is 24. Okay, this is the method of prime factorization. So after making prime factors, group them and arrange them accordingly. Then you take one element from one group, then find the product of them. Okay. Then if it is not a perfect cube, you won't be getting it as the pair of 3 each. Okay, 3 3 group, you won't be getting that. Now, cube root method of estimation. So how to use it on estimation method. So let's see. The first step is whatever number is giving it to us, you have to look at the unit digit. Okay. So some specialties we have learned regarding the unit digit of the cube numbers, right? So that we have to apply first. Then we have to cross the last 3 digits. If we have done that, we have to separate the last 3 digits from the remaining digits. Okay. And then if more digits are there in the eliminating, after eliminating 3 digits, we have, if more than that digits, we could find the number. We have to see that whether a number which is nearly reaching to that number, that is a perfect cube. What is that? So I will be telling this with an example here. For example, I have a question 373248. We have to find out the cube root of this number using estimation. First of all, the step 1 is to arrange them. That is the last 3 digits you separated. Then the remaining I have 3 digits here, right? This is the last 3 digits and remaining 3 digits. First of all, here, what is the unit digit? Unit digit is 8, right? So if a number is ending in, if a cube is ending in 8, what is the possible way to end the cube root of that number? It will end in 2. Okay. So you can understand the cube root consisting of the unit digit as 2. Okay. So we will fix it. Then the remaining digit is 373, right? So think of the cubes of numbers up to 10. So we know that. So on nearer to this, what perfect cube is coming? It is 343, right? That is the actually the cube of 7. So what is the cube of 7? 343, which is nearly nearly coming to this 373. So we can write that the cube root of that is 7. So you can write the next digit as 7. So the answer is 72. So this is the method of estimation. Okay, so you'll be getting the answer as 72. First you fix the unit digit, then the remaining digit, how many are there? You have to think of which perfect cube is coming to that particular value. It can be equal to that value or which is less than that value. So whichever is coming, you can take that. Okay. Then properties of cube roots. So what are the properties here? Like we have learned in the square root properties, here also the distribution of the surds are coming here. So cube root of a by b is equal to cube root of a by cube root of b. Very, very important. And cube root of a and cube root of b are integers, and cube root of b, which is coming in the denominator, cannot be 0. Now, so this is an example which I got for you. If the cube surd is there common, then we can distribute the surds. Here it is cube roots. We can distribute it and you can write the numerator and denominator accordingly. Then we will be finding the cube root of the given numbers. Okay. Then if a cube of a number is 2 or 3 digit, then the cube root will be 1 digit. See, either a cube of a number consisting of 2 digit or 3 digit. The cube root will consisting of only 1 digit. The cube of a number 4, 5 or 6 digit, then the cube root will be of 2 digits. Okay. 4, 5, 6 digit numbers are there, the cube root will be finding, you will be having 2 digits only in that. So very, very important points. Then the cube of a number have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in its units place. Then the cube root will have 0, 1, 8, 7, 4, 5, 6, 3, 2, 9. Here you can see just the place of 8 and 2 are interchanged and 7 and 3 are interchanged. Only that much, right? Yes. So that we have separately learned that all other digits are ending in the same digit itself. Now, there are only 3 numbers whose cube is equal to the number. 0's cube is 0, 1 cube is 1 and minus 1's cube is minus 1. These are the constant numbers where you are getting when you find out the cube of it, you are getting the same answer. Then, if p is an integer, the cube root of minus p is equal to minus of the cube root of p. So, an example we can say that is cube root of minus 27. Cube minus of cube root of 27 we will be able to write, and the answer when we find, just need to find out the cube root of 27 and the answer will be 3. Okay. And you can just put the negative symbol of it. You'll be getting it as minus 3. Okay. So that's all in this session. So I hope the session is useful for you. So please do comment. Okay, and this will be encouraging me to come with more sessions, and we'll be seeing a marathon session for the Q&A part, that is previous year questions, in the next video. Okay, so we'll be meeting soon. Thank you.